let's get to the demo and see how Openflow works in practice. All right. I'll start with SQL Server. Right? So right now, I'm in my IDE environment, which is connected to AWS RDS. This is where I created a database. If you're working with SQL Server, you might be very familiar. This is like a test database provided by Microsoft for Northwind, which is a retail chain and is basically selling products. So it has a schema called DBO. In that schema, there is a number of different tables. So this is, what I'm showing to you is that's really in the cloud, right? So I'm literally live connected to AWS RDS, and SQL Server is running there. And the first thing I need to do is I want to choose a few tables that I want to replicate real-time, like stream any changes from these tables real-time to Snowflake. So in order to do that, for databases like MySQL or Postgres, what I would do, I would enable transactional logs. So for MySQL, I would enable bin log. For Postgres, I would enable logical replication, right? So write ahead log. In case of SQL Server, what I need to enable is so-called change tracking. Change tracking is a built-in feature of SQL Server. And change track, they actually give you a few solutions for CDC, but change tracking is what we recommend because it's very lightweight. It doesn't require that much compute and memory, so it doesn't put any significant additional load on your source database, okay? So the way to enable it, I will run this command. First, I need to enable change tracking on the entire database. And then I need to enable change tracking on every single table that I'm interested in. So that will be orders, order details, products, and customers. Right now, SQL Server, whenever there is a change, which is insert, update, or delete, it will be captured in a change tracking table that is kind of corresponding table to the source table. Right? So let's have a look. How do the products look like? So there is 78 products in our inventory. The hero of the story is chocolate waffles. And let's see the orders. When was the latest order? This is a very old test data set. So you see that the latest orders were in 1998. OK, so I'm all set inside RDS. Let me move to Snowflake. I created a database with the same name, Northwind, inside Snowflake. But the DBO schema is not there, right? It only has this classic standard Snowflake schemas, information schema and public. So there are no, the DBO schema doesn't exist. The tables are not in there. So we need to bring them in. Therefore, I'm moving to Openflow. Right? Openflow is something you can find in your, if you are in AWS, then Openflow is already generally available there. That's what we announced on Tuesday. So if you log into your account, in the left navigation menu, under data, you will find the link to Openflow. Openflow will open in a separate tab because for now it's a standalone service, but it will be, the tighter UI integration is coming. So in Openflow, you can actually go to our Openflow connectors, right? Like I said, you don't have to start, you can start from scratch if you like, and if you're familiar with Apache NiFi, I would highly encourage you to do that because this is when you truly start unlocking lots of value from this technology. But if you want to get started quickly, you can go to our catalog of connectors and browse what is available there right now. Currently, there is around 20 different sources, right? That's spread across, like I was mentioning before, SAS, streaming, unstructured, and structured databases. The one that we're interested in is Microsoft SQL. So if I want to use a connector, which is like a template of an Apache NiFi data flow, I can just pick this, click add to a runtime, and I can choose what is going to be the Openflow runtime or deployment that I prepared before, where this flow will be running. And runtime is basically you're preparing a compute pool of resources for this particular flow to run and execute. So I have actually done that before the session. So now I entered my runtime. Those of you who are familiar with Apache NiFi, this should look, familiar. This is basically an Apache NiFi interface within the experience of here being fully managed and integrated into Snowflake Openflow. And it's actually extended with additional features over what you would find in the open source distribution. So the connector that I chose ended up as a so-called process group on my NiFi canvas or Openflow canvas. Process group is a collection of smaller, basically atomic components of that flow. So if I double click on it, you will see that this process group has two other process groups nested. One is responsible for initial snapshot load of tables, right? So I will be replicating those 4 tables. So this flow will take a snapshot of these 4 and put the entire copy of these tables into Snowflake. The other one is the incremental load, which means this is the one that will be monitoring change tracking tables, all the change events, and streaming them real time to the destination tables in Snowflake. So let's open up the incremental load and see what's inside. Like, how does the flow actually look like? There it is. You can see that it's actually pretty big. So let me zoom in. And this is the flow. So you can see it's basically a collection of steps, right? Every step is here manifested by a so-called processor. So every box is a processor. This is a small piece of code doing a certain task. Like, for example, the one at the top is I'm monitoring change tracking tables, and I'm basically capturing the change events, inserts, update, and deletes, right? The next one would be micro-batching all the events and pushing them through the process. So if we would scroll down, we would find another processor that is basically streaming the changes using Snowpipe streaming to your Snowflake account. And then if you would go further down, one of the processors at the very end would be a processor that would be actually triggering a merge statement in your Snowflake account to merge these incremental changes into your destination tables. And I'll explain this process a little bit in more detail later on, but I just wanted to give you a sense of what is actually an Apache NiFi data flow, right? So this is how it looks like, and our connectors are abstracting all this complexity, right? You wouldn't have to work with these boxes if you don't like to, but the beauty is that you can use it out of the box, and it will work, and it will have all the features like snapshot load, incremental load, table schema changes would be automatically captured and reflected. You can filter columns and so on and so forth. But on top of that, if you'd like to customize it and expand this flow, you can, right? You would basically pull a new processor, choose from our library of nearly 400 processors. Some of them, those with the droplet icon, come from the open source distribution of NiFi. Those with the Snowflake icon are provided by us, only in Openflow. And just by searching this library, you can expand this flow with so many additional logic and use cases. So I'm not going to do that. Let me go back to the top. So what I like to do right now is I want to tell this flow, hey, I want you to start replicating from that RDS instance those 4 tables. So I'm doing right-click and going to the parameters. I need to basically configure this flow, right? I need to enter parameters. So the parameters are grouped into parameters related to the source, to the destination, and into the data that I want to replicate. So for example, what's the destination table in Snowflake? What's the name of that table? What is the account in Snowflake where I want to send it? What are the credentials, like user, secure key? What is the warehouse that will be doing the merge statement? Then on the source, on SQL Server, what is the JDBC URL to that RDS instance of the SQL Server database? And I uploaded JDBC driver for that particular database, and then, again, credentials to authenticate, right? So I've already pre-filled most of these parameters before, but there is one that we need, the most important one, which is right now this flow wouldn't do anything because we didn't enter any tables, right? So I can either give a comma-separated list of tables in this input box. Or, and that's what I will actually do, I can use a regular expression, and I can say, I want all tables inside the DBO schema. So I can use a wildcard like this. And you can use wildcards to, for example, replicate tables with certain prefix, from certain schemas, from the entire database if you like. Then it will be, if you create a new table, it would pick it up automatically and so on. So I'm applying the changes, and now the flow will know, it's validating them, and now the flow will know what to replicate. But if you recall, I enabled change tracking only on 4 tables out of 10. So even though I'm saying, hey, Openflow, replicate everything from the schema, SQL Server only has change tracking for 4. So we're expecting only those 4 tables to be replicated. So before I start the flow, because the flow is still paused, right? This red rectangle shows that this is still stopped. I will actually show you another thing, which is if I click here and go to controller services, I can check the table state store controller service to see if any tables are being replicated right now. And it says no, 0 tables are being replicated because it's not running yet. So let me come back and actually finally start the flow. So right-click, enable all controller services, right-click again, start. It turned to green, and we can now again check the controller services. Check table state, view. Here you go. It actually added those 4 tables into replication, and it says it's already in the incremental load, which means that the snapshot has already finished. You can observe here how the data is flowing, right? So if you double-click further, you can see where the data is currently, what's in, what's out, how many kilobytes or megabytes have been processed, and so on. And you can even check every single processor, right? How many records and how many bytes each processor has already processed. Okay, so let's go to our Snowflake account and check whether the schema is there. Yes, DBO schema is there. If I expand it and I go to tables, there you go. The tables are there, but there is more of them. So let's actually check what does it really mean. So let's use that schema and show all the tables. So you can see that we replicated customers, order details, orders, and products. Those tables are in, but they also have this additional version of them, which is called journal. And here's the thing. So let me maybe switch to slides for a moment so that I can actually explain it. So here's what we're doing. Snowflake Openflow is checking the change data capture stream, right? So it's actually doing 2 operations in parallel. When you add a table to replication for the first time, it's using JDBC driver to do a select star on a source table and basically do that initial snapshot load of that table. At the same time, it starts monitoring the change data capture stream, and whenever there is a change event, insert, update, delete, it's basically using Snowpipe streaming to push this into your Snowflake account. And now, before the data lands in the destination table, the output of Snowpipe streaming is a journal table. It is an append-only table that is basically capturing all those change events. So you actually, inside Snowflake, you also have full history of all the change events that happened, inserts, update, and deletes, along with the payload, the time when it occurred, there's log sequence number, and all that metadata. So it is, I think, helpful in a way that, in case you have to, for example, audit what happened to a certain record in the past, you can do that actually inside Snowflake. So that's output of Snowpipe streaming stream. And the latency here is like seconds to up to a minute, right? Between the time we spot a change in SQL Server and the time it was streamed to that journal table, it is seconds, I would say maximum up to a minute. And then we need to merge these latest incremental changes into the target table. So we're basically running a SQL statement, right? A merge statement. Take this recent batch of incremental changes and reflect these in the destination table. So update these records, insert these new ones, or mark these records as deleted. We are not deleting, removing. records, we're actually soft deleting them. So we're just switching a flag that it is deleted. One thing that I also want to describe here is that this diagram shows the setup that I'm right now using in my demo, which means I have deployed Openflow inside my AWS virtual private cloud. So whenever I'm using, this NiFi canvas, etc., even though I'm entering this environment from Snowflake, I'm actually not in Snowflake. I'm actually in my AWS VPC. So you can see Snowflake is inside customer network on this diagram. There is an alternative option that I mentioned, like this, right? You can deploy Snowflake Openflow to run inside Snowflake, inside Snowpark Container Services. Okay. So let's come back to the demo. Now, what is most interesting is that big claim that I made at the beginning, that incremental changes will start flowing real time, right? So before I show you how it looks like, let me, okay, my notebook decided to suspend in the meantime, which is good. It's saving my credits. So let me revive it. So I want to obviously do some analytics on this data, right? I want to know whether I need to stock up my store with sufficient number of chocolate waffles because there is no interest for that, right? So let me run my quick analytics. I have this notebook inside Snowflake where I can see, okay, so this is history of orders of different products per day. This is the top 5 selling products recently. No chocolate waffles, so probably I don't need to stock up. The history of waffle orders was kind of, well, no, not many of them, some occasional from time to time. So that is why I have 0 waffles in my stock. And in last 5 minutes, there was absolutely 0 orders for that product. But apparently somebody made a TikTok campaign how great it is to eat chocolate waffles and record selfies with them. So we might actually get surprised. So here's what I'm going to do. I'm going to SQL Server, and I will start a script that will be placing order for chocolate waffles every 5 seconds for 5 minutes. So let me start that. Run. It kicked off. Let's start checking the latest orders in our order table. Okay, so I have now 2 orders from today. Let me refresh again. Now it's more. Right? So you can see those orders keep coming. Every 5 minutes, we actually have a new order. Let's check what is happening in Openflow. So if I go here, you can see that incremental load actually started capturing some change events that are queued at the moment, so they will be processed very soon. If I go to here, and if I start, so I'll find this journal table for orders, the latest name, copy name, and we'll try to query it. Let's see if any of these changes have been replicated. Not yet, it's still coming. Okay, let's see how many changes we have here already. More and more coming. And there you go. Suddenly, in our journal table, we actually see that 13 new orders have been captured. These are new records that appeared in the orders table, right? So they are now here in the journal, captured as change events, right? So we can actually see what is the type of the event. It is incremental insert of rows. And what was the offset token inside, what was the sequence of these changes in the log. So if I now check orders here, I should also see these records. And here they are. These are the records that we have just created. So then if I go to my notebook, and if I run this graph again, there you go. In last 5 minutes, more than 800 waffles have been ordered. Right, so you can see, and now this pipeline runs continuously, and it's, all the orders in the source would be immediately streamed to Snowflake and reflected in our analytics real time. All right, so that's for the demo.